Hi class, today's lesson is lesson 7-6. Today's purpose is to read and use map scales in drawings. And this is where proportions can come in mighty handily. We've got a couple of vocabulary terms. The first is scale. Scale. It's the ratio between two sets of measurements. If we look at the illustrations down below here, we have two sections of a map. Here we have a ratio, 1 inch equals 250 miles. So 1 inch on this map is equivalent to 250 miles on the actual ground. Here we've zoomed in on the Atlanta area. So 1 inch now equals only 20 miles. So this is all of the Atlanta area. Now we look at the ratio over here, and that tells us that something that is 1 unit on this map is actually 16 million times bigger in real life. So the distance from Atlanta to the Atlantic Ocean, if we were to translate that into real life, is 16 million times bigger than that particular line segment that we would draw. Our next vocabulary term is scale drawing. A scale drawing is a drawing that uses a scale to make the object smaller than or larger than the real object. Here we have a bird's eye view of a room. In this case, it's the bathroom. And I've used these as we've remodeled our house. These are walls, of course, here, windows, a bathtub, a toilet, and then it gives us a scale down here, a 1/4 inch. For every 1/4 inch that we see on this actual diagram, it equals a foot in real life. There's our ratio, a scale drawing. For our first example, it says here, on the map, the distance between Wrigley Field and the Shedd Aquarium is approximately 3.3 inches. It's interesting, this particular illustration, because my wife actually lived about a block away from Wrigley Field. So Wrigley Field here, Shedd Aquarium all the way down here. And if we measured it on the map, it would be 3 3/10 inches. Well, what does that mean in terms of our scale? Well, here's our scale. It says 1 inch equals 2 miles. So we're going to set up a proportion. 1 inch equals 2 miles. Now we're going to set up another ratio on the other side, and we're going to say, well, that's 3.3 inches. It goes on top because we see that inches go on top. And then we'll have the actual distance, d, be a variable. If we go ahead then and cross multiply, we have 1 times d is d, 2 times 3.3, or 3 3/10, is 6 6/10. What would that be? It would be actually miles. 6.6 miles from Wrigley Field to Shedd Aquarium. Next example, we have a scale drawing of Mercury and Earth, and the scale says 1 inch equals 30 million kilometers. Our first question is, what is the actual distance from Mercury to Earth? We're going to go ahead and take this ruler and measure the distance from Mercury to Earth in inches, and it looks like we've got 1, 2, 3 total inches. So it is 3 inches on the scale drawing. What does that mean for within for real life? Within this ratio, we're going to write down 1 inch equals 30 million kilometers. Okay. With that said, I'm going to put the 3 inches on top because that's where inches are, 3 inches. And then I'm going to put the distance d, a variable, down here. Then I'm going to go ahead and take and cross multiply. In this case, 1 times d is d again. 3 times 30 is 90. Now 90 what? Well, we're converting to 90 million kilometers. So my answer is 90 million kilometers. That's the actual distance from Earth to Mercury. We have one more problem, and it's the actual distance from Mercury to Venus. Now, it's not dependent upon this illustration. From Mercury to Venus is 50 million kilometers. How far apart should Mercury and Venus be drawn? So we're doing the opposite here. We're going to use the same scale. 1 inch is to 30 million. And this time, we're trying to figure out how much 50 million is. And what should that distance be in inches on a diagram? So we're going to go ahead and do cross products. Another way of saying cross products is cross multiply. So we have 50 over here, 30 times d over here. And then in order to isolate the variable, we have to divide by 30. So 50 divided by 30. D equals, well, what number? So let's go ahead and do that. 50 divided by 30, I could actually just take out the zeros, and that'd be 5 divided by 3. 3 goes into 5 once. Now I've got to add a 0.0, bring down the 0. 3 goes into 20 6 times, 18. And I bring down another 0. It looks like I'm going to repeat 66666. So I'm going to go ahead at this point and say it's 1.7 million kilometers. Oops. Now I've just made a grievous error. You see what I did? I mislabeled it. I'm not thinking correctly here. What I was looking for is how far apart should Mercury and Venus be drawn on a diagram like this. We're looking for inches, distance in inches. So inches would be 1.7 inches. Your challenge is to complete this problem. If a drawing of the planets was made using a scale of 1 to 30 million kilometers, which is the same that we just did, the distance from Mars to Jupiter on the drawing would be about 18.3 inches, or 18 3/10 inches. What's the actual distance from Mars to Jupiter? Go ahead and set up your proportion using this as your ratio, this as a number in the proportion, and d as your distance. See you in class.